Welcome to my tutorial how to integrate third-party devices to Powercenter 3000. This is possible for all devices with support for Modbus communication. This could be direct Modbus TCP communication to the third-party device, or also it is possible to use Modbus RTU communication. For this, an additional gateway for translating Modbus TCP to Modbus RTU is required. For my tutorial, I'm using a Semantic S7 PLC, which is equipped with a precompiled program Energy Data Collector. This is available in Siemens Support Portal as free download and can be used to collect some energy data or measured values and provides this by Modbus TCP communication. For Powercenter configuration, the software Powerconfig is used. I already prepared a project with included Powercenter and with working communication to it. Now we can add all regularly included devices, or we add our third-party device with this icon Modbus device. Drag and drop it here, and let's rename it to EDZ 1214 because it's our energy data collector based on a Semantic PLC S71214. Also, this EDC device is running in my network and can be accessed by web server and Modbus communication. First, we have a look in the manual of this EDC device. The most interesting thing here is the Modbus register list. Here we get an overview which value and on which address and data format is available. Here we have counter 0 to counter 13 and 2 analog values which we can integrate to Powercenter. And for this, we continue using Powerconfig and go to parameter of our Modbus device. The first step is to configure a number of categories and a number of data points. Categories are required to group data points. For example, we can have category voltage, energy, power, or something else. And this is the quantity, how many categories we want to have. For EDC, we have counters and analog values. So here, it's a good thing to choose two different categories, one for counters and one for analog values. So we need two categories. And these categories we can also give a custom name. Name the first one energy counter. And the second one analog values. I'll just keep it analog. Okay. And in the next step, we have to define the number of data points. Each value we want to add is one data point. So for the energy counters, we need 0 to 13, so complete 14, plus 2 for the analog values. So complete we need 16 data points. And also here our 16 data points appear. To configure data points, we start with the first data point, and always I strongly recommend to configure one single data point, test it, and if this works, then configure all other data points. So our first data point should be energy counter 0. custom name is set. Then we have a uniform name, like you also see here in the description. Uniform name is only required if you want to combine this with Centron Mind app. Here in my application, it's not used, so we do not need it. Then we have category, and here we find our both configured categories, and let's choose energy counter. Next thing is register address, and this register address we have to pick from the manual. Here in manual, the counter 0 starts with register address 1. So let's add here register address 1, and register count, it's already pre-configured with 2. This fits here to the given length of 2 registers. And the format of this value is float32. Also, this must be given here as a float format, which is already pre-configured. The other stuff for configuring some bits and bytes, I would say it's a more detailed thing, and in the most applications not really required. So I will skip it. Also in my application, it's not required to do some configuration here. But we have to configure a unit and a display format. My energy data collector should collecting some energy pulses and count these pulses in kilowatt hours. So let's say my unit are kilowatt hours, and then configure the format. If scale is used, Powercenter does automatically and scale in the unit and sets an automatically prefix for kilo, mega, giga, and so on. So this means if the value reaches 1000, kilo is added. If it's reached 1 million, mega is added, and so on. But here we have a fixed unit. It's always kilo. So we do not use scale. We're using this x, what means it's a fixed value with a unit which we set here. And finally, we can choose runtime settings archiving for this, if this should be archived. I think for energy counters, archiving, it's a very useful thing, and we should activate it. Then save it. And before we start configuring next, we should first test this one single data point. Because one very often existing, let's say, problem, it's the register address. Here I directly use register address 1, like it is set also here in the manual. Sometimes here are some differences between the manual and the configuration software, because some systems start counting by 0 and some systems starts counting with 1. So if you have some problems here, you have to play a little bit with the start address and may adjust your address with plus or minus 1. So for example, if 1 does not work, try 2 and then test it. And if you know how to set your address here and everything works, you can continue to configure all the other data points. And now let's have a test to this first data point. So we have also to adjust the communication settings. Which IP address is our device available? And Modbus address normally is 1 for TCP devices. If you have some RGU devices with gateway, care about this Modbus address in detail. And now switch to measurements. Our category and the counter 0 is shown, and we can go online and check and see energy counter 0 is already showing a value of 10 kilowatt hours. For this, I have a look in the web server of my device and check it also here, and I see energy counter 0 as 10. So this is the correct value, and my configuration is fine. And now I can continue and configure all other data points. Here I already prepared a project to speed a little bit up. Here my configuration for data points is already prepared, and I have also configured my next data point. Here in principle it's exactly the same doing like before, only differences. We have the name for energy counter 1 and we have an other register address. So here I used 3 as address. If I look in the manual, we can see counter 1 starts with register address 3. The 3 is also used here. And the same is also for energy counter 2. We have register address 5, like manual 5, and so on. Last two data points I configured as analog value 0 and analog value 1. This I have sorted to the category analog value, and here I used volt as unit. And also here I add the register address regarding the manual of analog value 0. Now we can test it and switch to measurement and go online. All values are looking fine. And if I look in the web server of the device, the values are correct. Perfect. Now we can transfer this project to Powercenter. For this I switch to web server of Powercenter and load my project. Select the Powerconfig file and transfer it. And my EDC here collects as an own device. After loading, the start page here is empty. This is because we have to add some widgets. This can be done here. And now I find my categories. Let's have energy counter, also analog values. And I can also add some archive charts. In the archive chart, I can select all my values which are configured with archiving. And so my energy data collector is integrated to Powercenter. Finally, a very cool thing is I can export my device configuration and use it once again in some other projects. So do one right click on this device and say export device. Give it a name and save it separately. And saved here as an own file. If you have a new project in Powerconfig, we can add this device here by right-click, import, select our device, okay, and now it's also available here. And so you have for this device type only one time the engineering, and then you can use it all the time. I hope this tutorial can give some help to you, and thanks for watching. Bye bye.